So let's look at the full Schrodinger equation. We have minus h bar squared over 2m. We have the radial part, so two derivatives in r of psi plus 2 over r the psi by the r, plus now we have the angular part. So we have two derivatives in theta plus the cotangent of theta and one derivative in theta plus 1 over r squared sine squared theta, two derivatives in the other angle, phi, plus the potential, and that's equal to E psi. Right? Time independent Schrodinger equation. And we make the assumption that we can break this up into two pieces. In fact, into three pieces. We'll break this up. We'll assume this can be broken up into a piece that depends on that and one that depends on that. And the general solution will be some combination of these kinds of solutions. We know we can do that. So what does the Schrodinger equation become in this case? Here we only operate on this object, and so we'll take this y part out. And we'll have that and that, where this is this function. Then we have that function over r squared, right? Because we're doing this. So we're pulling this part out, but we have to operate on this part. So we have two derivatives in this y function, and we'll be able to see later on that we can break this part up into two pieces. Two derivatives of the y function, so we pulled out the r function, in phi plus v psi equals E psi. Okay, so at this point, we can separate these out further. If we divide by psi, let's divide by this, and multiply by, let's see, minus 2m, sorry, 2m r, little r squared over h bar squared, that will give us this. So we'll end up with little r squared over capital R, two derivatives in the capital R function, plus 2 over r d capital R and little r, plus 1 over this y function, second derivative in theta of that y function, cotangent of theta dy d theta, plus 1 over this y function, sine squared theta, second derivative of y in phi minus 2mr squared over h bar squared v is equal to minus 2me r squared over h bar squared. Let's bring this over to here, and all of this ends up being part of this. Let's just do that. For visual effect, we'll combine all things that need to be together. Two derivatives in this, r plus 2 over r dr by dr. We'll combine all of that. We'll get minus 2mr squared over h bar squared v minus e plus this other part. So these two pieces will be, they have to act together. They are of different functions, r and the theta phi part, and they will have to add up to 0. So here we have two derivatives of this other function of the angles. Right, nothing that I'm writing now depends on this variable r, cotangent of theta dy by d theta plus 1 over capital Y sine squared theta, two derivatives of capital Y in the other angular coordinate phi, and that has to add up to 0. And so we can see that for these two things to add up to 0, this, which depends only on that coordinate, and these pieces, which depend only on these angular coordinates, they must individually be constants. And so normally we say that this whole thing is some constant. I think we use the symbol lambda, and therefore this whole thing here has to be minus that constant for that to be the case. And then separately we can then further break these things down given this, and we'll see how to eventually get to the full solution psi.